In today's video, we will disclose some systematic, easy way to solve some questions under work, energy, and power. We all know that work is the product of force and a particular distance. Sometimes in physics, you can derive your formula from your definition or law. If work is the product of force and distance, therefore W equal to F times D. We all know that the unit of work is Joule, that of force F is Newton, and that of distance D is meter. A question says that if a force of 2 Newton that was applied on a box over an unknown distance, find the distance if the work done is 6 joules. To solve this, list out your quantities, its magnitude, and its unit. Our F equal to 2 Newton, our D is unknown, our W is 6 joule. The formula to apply is W equal to F times D. You can make D the subject of the formula since we are told to find D, or infuse the value directly. Let's infuse it directly and have our answer. Now we have W equal to FD as 6 equal to 2 times D. Then divide both sides by 2. Then we have D equal to 6 over 2. And when we divide 6 by 2, we have 3 as the answer. So the distance covered is 3 meters. Now another question says, if the force applied is twice of the distance along 30 degrees to the horizontal ground, find the work done if the distance is 2 meters. First, write out the quantities, magnitude, and its unit, just to show your plan or blueprint. Our angle equal to 30 degrees, that's our theta. Our distance is 2 meters, and if the force F is twice of the distance D, then F equal to 2 times D. F equal to 2 times 2 if D is 2. So my F equal to 4 Newton. Now the formula is W equal to F times D with cos theta due to the horizontal angle. Infusing these values, we have W equal to FD cos theta. That's W equal to 4 times 2 times cos theta. Our cos theta equal to 0.8660. W equal to 4 times 2 times 0.8660. So therefore, the work done, W equal to 6.928 joules. Or you can say 6.9 joules or 6.93 joules. Now moving to energy. Energy is the ability to do work. We have forms of energy, and under the forms of energy we have mechanical energy, and in the type we have the kinetic energy, the Ke, and the potential energy, the Pe. You can call the kinetic energy the dynamic energy that is dealing with movement, and you can also call the potential energy the static energy. Kinetic energy has a formula which is Ke equal to 1 over 2 mv square, or mv square over 2, or 0.5 mv square. M is the mass in kilogram and v is the velocity in meter per second. Now the formula for potential energy, the Pe, equal to mgh. The m is the mass, the g is gravity, and the h is the height. Now let's move to a question. I have this diagram. If the velocity when the ball falls to the ground is 2.5 meter per second, find the kinetic energy and the potential energy, that's the Ke and the Pe. Starting from the kinetic energy, our formula is Ke equal to 0.5 mv square. Therefore, our kinetic energy when infusing the value, the mass value, and the velocity value, I have 0.5 times 10 times 2.5. Now, our Ke equal to 12.5 joules. Now, we have to understand that the unit of energy and the unit of work are the same together. And the Pe equal to mgh. M is 10 kilogram, the g is 10 meter per second. Now, that is a constant quantity, and the h equal to 100 centimeter. The SI unit of height is meter, so we have to convert from 100 centimeter to meter. Therefore, 100 centimeter divided by 100. So we have 1 meter. Now, our PE equal to mgh as the formula. Now, infusing the numbers, I have PE equal to 10 times 10 times 1. And when we multiply all values together, I have 100 joules as my potential energy. Moving to the last aspect, the power. Power is a ratio of work done over time. Through this definition, we can derive the basic formula for power, that is, P equal to W over T. We must not forget that work, energy intertwine together, so we can also derive another forms of formula by placing the kinetic energy and the potential energy in the place of work. Therefore, P equal to 0.5 mv square over T, or P equal to mgh over T. If you check the P equal to mgh over T, that's the second formula. Mgh is connected to force formula. That's F equal to mg or F equal to ma. So we can have P equal to Fh over T as another formula for power. And if we check h over t is connected to velocity, v equal to h over t, that is specific height over time. So we can also have power as P equal to Fv. So all these formula so far are P equal to W over T, P equal to 0.5 mv square over T, P equal to mgh over T, P equal to Fh over T, and P equal to Fv. We can use all of this to solve any question pertaining to power with the respect of quantity present in the question. That is, the quantities present will determine the formula to use. If your question contains force and velocity, then you use P equal to Fv. And if it contains the mass, the time, and the velocity, then you use P equal to 0.5 mv square over T. I will show you a question on power. Solve it in the next 25 seconds before I show the solution.